Let's go through a method invocation example. We have two methods or static methods. The very first one is your static main. This is a console application, and the second one is your static max. Both of these are static methods. Max is a method that takes in two arguments, number one and number two, and compute the maximum of the two numbers. And your main function, or the point of entry for the console, is responsible for one, initializing two integers, I and j, to 5 and 2 respectively, and pass them in as arguments to this static method called max, which returns the maximum value of either I or j, and then print it to the console using system out line. So this is the whole context. Let's go through each step. You have what's called the declaration of I, integer I, and integer j. Integer I is initialized to a value of 5. This sets aside 2 bytes of memory space. So integer with a value of 5, labeled I, is in this memory space, and this is 2 bytes. That's number one. This values is inside your computer stack memory. Next up, we have j, which is another 2-byte integer, and it could be sitting right here with a value of 2 through initialization after creation with the label j. Next up, this is where the method invocation happens, where I and j becomes what's called the arguments. These are the arguments that you will pass into this max method. Let's look at what happens internally when the function scope is established. Your entire flow of control now goes into this function at whichever line in your code where the passing in of your integer ij happens. So this num1 would assume at this point a value of 5. Num2 would assume a value of 2 because they were I and j respectively. So that's what happens when you first get into your function. Let's see what happens next. Remember, both num1 and num2 is what we call parameters. They are parameters inside this method, but the values that we pass in to invoke these functions are what we call arguments. That's the difference between the two. We talked about this before. When inside your function, the very next step is to declare this variable called result. So this actually happens, let's say here, you have this variable called result at this memory location. By default, uninitialized integer has a value of 0. So this thing is actually 0, even if you don't initialize it. In other languages like C++, the behavior or the value of results would have been what's called undefined, because these languages don't have the default mechanism to set this value. So it becomes really important for you to do so in those languages, but not in Java. Let's look at the next step. For the sake of illustration, let's also erase the screens to make it clear. Now we are inside this conditional block, or if and else. Your if is checking this conditional statement, number 1 greater than number 2. And we know number 1 is 5, number 2 is 2. So this will evaluate to true at this point. This means also that your flow of execution is going to its immediate next line, which is results equal number 1. This effectively sets the value of your result to number 1, which is the greater of the two arguments. Next up, there's nothing else because your entire flow of control is going to get out of your if and else, going straight to the result to return. And notice that your result is 5, the greater of the two arguments. At this point, your flow of control is going to completely exit this pair of curly braces, what we call functional scope, and back to your main. And because max returns a 5, this value of 5 is going to be in your variable k. And this is the same memory count. Maybe here is where the k is, integer 2 bytes at this location with a value of 5. Next up, we're going to system out print line. So remember, this is printing the entire string that you have concatenated in this fashion to your console with a line break. is ln at the end of print. Your print statement is going to be the maximum between, and there's going to be a space, 5, space end, space, 2, space is space, 5. That's it. This is how a method is invoked from another method. By and large, even if you don't have this thing static, which means these would have been a method that is a part of a particular instance, you'll use the instance reference object notation dot its max to invoke it. So syntax is a little different, but the idea is the same for any method or function invocations. Let's look at a few things regarding the return type and return data when invoking a method. In this example, we have a method name called sign. Depending on what gets entered, this integer end. If integer n is greater than 0, you return 1. If the integer is 0, then you return 0. However, if this integer is a negative number, you return -1. Now, here's a problem. In this version, you have if, else if, else if. Now remember, else if only carve out a necessary space. Let's say this is your problem space by that domain. And this could be an else if. And then you have a whole bunch of else if. There's also an if. Imagine that this entire cloud is 100% of your problem space. You need an else to really cover the remaining possibility, but there is none. Looking at this version on the right side, you do have an else. This effectively covers all of the problem space, regardless what its end is. Even though this logic is not wrong, because technically you would have either n be a positive, negative, or 0. But your Java compiler has some sort of logic that thinks from a syntax standpoint, there's something in amiss. So this becomes a problem, is a warning. And sometimes the warning can become compilation errors. This will prevent you from compiling your code into a bytecode for your runtime environment. So as best practice and resolution, let's clear this. You'll delete this part because 33+% of your problem space is going to be either this or this or this. So the very last 33% or 33.333 all the way through really don't require this. So just delete that part and the rest of it will compile. So this would be the correct version of it. Since we're at it, let's talk about the reusability of a method like your max. Why do we create a method like this? It turns out for reusability purposes, whenever you create a method, it is meant to be reused because you don't have to repeat the same logic over and over again. Let's say if you have a test max, which is a test runner that tests various usage of max by calling it one after the other. If you have to write out the if and else all the time, your test max is going to be huge. So instead of doing that, we create a method. And this is more of a modular way of constructing your code where pieces of your logic can sit inside their respective methods, or sometimes they call it function, so that they could be invoked over and over again. This will shave off your code size a lot. It is also true that by invoking methods or functions, you're incurring stack memory, which is something that we're going to talk about later. But overall, the benefit outweighs the drawbacks. Another thing of note is that if the method name is static, we use the class name to invoke it, kind of like integer.parseIn, where parseIn is a static method, and then we just invoke it by attaching an integer name to it. If a method is not a static, then we use the instance reference object name instead. We'll talk about that later. This should conclude all of the topics that we like to talk about and discuss in method invocation.